Hey everyone! Ever looked at your computer and just wondered how it can do thousands or even millions of things in the blink of an eye? Well, it's not magic, I promise. It's all about teaching the machine how to repeat itself. Today, we're going to get into one of the most powerful, fundamental ideas in all of programming: loops. So, to get started, let me ask you a question. What could your morning routine and a computer program possibly have in common? It sounds a little weird, I know, but the answer really gets to the heart of what makes code so incredibly powerful. It all comes down to repetition. Just think about it for a second. Every single day, you probably follow a similar pattern, right? You wake up, you brush your teeth, you make some coffee. It's a sequence, a routine that you repeat over and over. Our lives are just full of these little loops. And that's the perfect way to start thinking about how we tell a computer to do the exact same thing. Now, look, telling a computer to do something just one time, that's super easy. A single line of code like this one here. Print hello. It does exactly what you'd expect. It's simple, it's clean, it's direct. But what happens when doing something just once isn't enough? Yeah, what if you needed to say hello 100 times? I mean, sure, you could copy and paste that line of code 99 more times, but you can already see how messy and tedious that would be, right? And what if it was 1,000 times? 1,000,000? No way. There has to be a smarter way to do this. And of course, there is. This is where we meet the loop. You can think of a loop as this really elegant command that tells the computer, hey, see this block of code? Keep doing it over and over again until I tell you to stop. Honestly, it's like a programmer's superpower for getting rid of all those boring, repetitive tasks. So instead of writing out 10 different print statements to count to 10, we can just use a simple loop. Look at this. With just 2 lines of code, we can tell the computer to count all the way from 1 to 10. That's the real beauty of loops. You get huge results with very little code. Okay, so when you decide you need a loop, you've basically got 2 main flavors to choose from. First up is the for loop, which I like to call the planner. You use this one when you know exactly how many times you need to do something, like checking off every single item on a shopping list. On the other hand, you have the while loop, which is more like the watcher. It just keeps on running as long as a certain condition is true. Think about stirring a pot of soup until it's smooth. You don't know if that's going to take 1 minute or 5 minutes. You just know the condition for stopping. Let's run with that shopping list idea, because it's a great example. Here's a really simple list: apples, oranges, and bananas. We want our program to be able to look at this list and do something with each item. This is the perfect job for our planner, the for loop. So check this out. The for loop is like a little robot that goes through our list. It grabs the first item, apples, and prints it. Then it automatically goes back, grabs the next one, oranges, and prints that. It just keeps repeating this exact process until it hits the end of the list, and then it knows it's done. It's just a super clean and efficient way to handle each item one by one. But what's really going on inside the computer's brain? How does a loop actually think? Well, it follows a pretty simple set of rules. It sets up a counter, maybe starting at 1. Then it asks a question, a condition. Is this counter less than 5? If the answer is yes, it does the action. It prints the number. Then, and this is the absolute key, it updates the counter, adding 1 to it. And then, it makes that return trip. It jumps right back up to step 2 to ask the question all over again. That little jump is what makes a loop a loop.
Okay, so this whole process is great, but it brings up a really important question, one that every single programmer runs into. What happens if that condition, that question we keep asking, what if the answer is always yes?
Well, that, my friends, is how you create an infinite loop. It's a loop that gets stuck and just runs forever because it never reaches its exit condition. The analogy here is perfect. It's like a program that's a car with a stuck accelerator and a gas tank that never runs out. It's a classic beginner mistake, but the good news is it's really easy to avoid once you know what you're looking for. And here it is. This is the #1 golden rule to avoid getting stuck. Something inside your loop absolutely must change in a way that will eventually make the condition false. Remember our counter? We added 1 to it each time. That little change is what guaranteed that eventually the counter would not be less than 5 and the loop would stop. Without that change, it would just print the number 1 forever and ever. All right, so let's do a super quick recap. Loops are your absolute best friend for automating repetitive tasks. You've got for loops, the planner, for when you know exactly how many times you need to go. And you've got while loops, the watcher, for when you're just waiting for something to change. And the most important rule of all, always make sure your loop has an exit strategy. When you get right down to it, understanding loops means you understand the basic idea behind all of automation. So I'm going to leave you with a little thought experiment. Now that you know how to do this, what's the very first boring, repetitive task in your own life that you would teach your computer to do for you? Thanks so much for